You may be living inside a black hole, not falling toward one, not watching one from far away, inside one. And that black hole may be inside another universe, which may itself be inside another black hole, hidden inside another universe, repeating downward into a cosmic chain with no obvious beginning. It sounds impossible at first, but the universe has never promised to make sense at human scale. A black hole is already a warning that our ordinary imagination is too small. We describe it as a place where gravity is so strong that even light cannot escape. That is true, but it is not deep enough. A black hole is not merely a dark object. It is a region where space-time is bent so completely that the future itself changes direction. Outside a black hole, you can choose paths. Inside a black hole, every future points inward. That alone should make us careful, because whenever time and space begin to trade roles, the universe is telling us that we are no longer in ordinary territory. Now begin with a simple question. What does it take to make a black hole? Most people imagine crushing matter violently. Take a star, squeeze it smaller and smaller, pack its mass into a tiny region, and eventually gravity becomes so strong that nothing escapes. This picture is not wrong. Massive stars can die this way. Their cores collapse, and if enough mass remains, a stellar black hole is born. But there is a stranger way to think about it. A black hole is not created only by density in the everyday sense. What matters is whether enough mass is contained inside a small enough boundary. If the escape speed from that boundary reaches the speed of light, the boundary becomes an event horizon. This is why any object has, in principle, a black hole size. Compress Earth to roughly the size of a small coin, and Earth would become a black hole. Compress the Sun to only a few miles across, and the Sun would become a black hole. The rule is simple. The more mass you have, the larger the event horizon can be. But now comes the first mystery. If larger black holes have more mass, why can their average density become lower? This sounds backwards. A black hole feels like the densest object possible, but the size of the event horizon grows directly with mass, while the volume inside that horizon grows much faster. Double the mass, and the horizon radius doubles, but the volume grows like the radius cubed. So as black holes become larger, their average density can actually decrease. A stellar black hole is incredibly dense. A supermassive black hole can have a much lower average density. An enormous enough black hole could have an average density that sounds almost ordinary. That does not mean it is safe. Do not confuse low average density with gentleness. The event horizon is still a boundary of no return. The geometry is still extreme, but the mathematics teaches a strange lesson. Black holes are not always made by packing matter into a tiny dot first. Sometimes the horizon can become vast. This opens the door to a disturbing thought. What if you gathered an enormous region of extremely thin matter? Not a star, not iron, not a dead core, just a vast amount of very thin cosmic material spread across an immense volume. Could that become a black hole? The answer depends on the geometry, expansion, and full cosmological setting. You cannot treat the entire expanding universe like a simple ball of matter sitting quietly in empty space. That would be too naive. But the thought experiment is powerful because it reveals something unsettling. The universe does not need matter to feel dense locally in order for gravity to become cosmic. On Earth, density means something your hands understand. Rock is dense, air is thin, space is emptier still. But gravity does not ask how matter feels to your hands. Gravity asks how mass and energy shape space-time. So now ask the second mystery. Could the observable universe itself be inside an event horizon? The part of the universe we can observe is enormous, tens of billions of light years across. It contains galaxies, gas, dark matter, radiation, and everything whose light has had time to reach us. Spread out on average, the universe is extremely thin. A few particles in a vast darkness, almost nothing. And yet, if you do the rough black hole comparison, The mass inside the observable universe seems large enough to make the question unavoidable. Are we inside something like a black hole? At first, the answer seems to be no. Our universe is expanding. Galaxies are moving away from one another on large scales. Space itself is stretching. That is not the simple picture of matter collapsing inward toward a black hole singularity. If you imagine a black hole as only a cosmic prison where everything falls inward, the expanding universe does not look like the inside of one. But physics becomes dangerous when the words "looks like" enter the room, because the inside of a black hole is not what ordinary imagination expects. From outside, a black hole is simple. It has mass, it may spin, it may have charge, it has an event horizon. It appears as a dark region surrounded perhaps by glowing matter and distorted light. But inside, the meaning of direction changes. The singularity is not simply a point sitting in the middle like a marble at the center of a sphere. In the classical picture, once you cross the event horizon, the singularity is in your future. It is not a place you can avoid by steering left or right. It is more like tomorrow. You do not move toward it because you choose to. You move toward it because time carries you there. This is the part that should disturb you. Inside a black hole, the singularity is not waiting at the center of space. It is waiting at the end of time. Of course, we must be honest. When our equations speak of infinite density, infinite curvature, and a singularity, they may not be giving us the final truth. They may be telling us that our current theory has reached its limit. General relativity is magnificent, but it does not include quantum gravity. At the center of a black hole, we expect that a deeper law is needed. So I would not say physics simply dies there. I would say our present language begins to fail, and when language fails, imagination rushes in. Now comes the third mystery. If a black hole's interior collapses toward a singularity, could that collapse become a beginning somewhere else? This is where science touches the edge of speculation. Some physicists have wondered whether what appears to us as the death of matter inside a black hole could, from another side of the geometry, resemble a birth. Perhaps the collapse does not end in a final zero. Perhaps quantum gravity prevents infinite compression. Perhaps instead of a singularity, there is a bounce. A collapse becomes an expansion. An end becomes a beginning. A black hole becomes the seed of a new universe. This idea is not confirmed. It is not something we have observed. It is not a standard fact like the expansion of the universe or the existence of stellar black holes. It is a speculative possibility, beautiful, dangerous, and difficult to test. But it is thinkable. And sometimes in physics, the fact that an idea is thinkable is already astonishing. Imagine matter falling into a black hole in our universe. From outside, nothing dramatic needs to change. The black hole remains dark. It gains mass. Its horizon grows. To distant observers, it is still just a black hole. But inside, if the singularity is replaced by a bounce, the story may be completely different. Space-time could open into a new expanding region. A baby universe could be born behind a horizon, forever hidden from the parent universe that created it. From outside, silence. From inside, a beginning. This is the kind of idea that feels almost impossible to hold in the mind. A black hole, which looks like the ultimate ending, could be a doorway to creation. Not a doorway you can travel through and return. Not a portal for spaceships. Not science fiction escape. A one-way cosmic birth, sealed behind an event horizon. And if one black hole can do this, then every black hole might be a seed. Now ask the fourth mystery. If black holes create universes, what kind of universes would survive? Here the idea becomes even stranger. Suppose each black hole gives birth to a new universe. Suppose the new universe inherits laws of physics, similar to the parent, but not perfectly identical. Tiny changes in constants. Tiny changes in particle masses. Tiny changes in how stars form, live, and die. Then universes would not merely exist, they would reproduce. And if they reproduce, they could be subject to something like selection. A universe that makes many black holes would create many daughter universes. A universe that makes few black holes would have fewer descendants. Over unimaginable cosmic generations, the universes best at producing black holes could become the most common. This is the idea sometimes called cosmological natural selection. Survival of the fittest, not for animals, but for universes, not claws, not teeth, black holes. If this is true, then our universe might have the laws it has because those laws are good at making stars, and stars are good at making black holes. And here comes the beautiful side effect. A universe good at making stars is also a universe where chemistry becomes rich. Heavy elements are forged, planets form, long-lived stars provide steady light, worlds cool, molecules gather, life may become possible. So perhaps life is not the target. Perhaps life is the side effect. The universe may not be optimized for us. It may be optimized for black holes. And we are here because black hole-making universes also happen to make galaxies, stars, carbon, planets, oceans, and eventually minds capable of asking where they came from. That idea is both humbling and magnificent. You are not the purpose of the cosmos. You may be the echo of a deeper cosmic reproduction. But now, we must stop before wonder becomes belief. This idea is speculative. It may be wrong. It may be impossible to test. It may be a beautiful mathematical story rather than the true history of existence. And yet it forces us to ask a question larger than almost any other. What if black holes are not the end of the universe's creativity? What if they are how the universe continues it? If this possibility is true, then every black hole is not merely an ending. It is a locked nursery, a place where matter disappears from our view, but space-time may begin again beyond a boundary we can never cross back through. Think about what that means. When a massive star dies, its core collapses. To us, it becomes a black hole. It falls silent. It hides its interior behind an event horizon. Astronomers outside may measure its mass, its spin, perhaps its charge. They may watch it bend light, swallow gas, and alter the motion of stars. But if a new universe forms inside, no telescope outside can ever confirm it directly. From our side, the black hole is darkness. From the other side, it may be a beginning. This is the strange cruelty of horizons. They do not merely hide places. They separate stories. The story outside says collapse. The story inside may say expansion. The same event, viewed from different sides of space-time, may look like death in one universe and birth in another. That is why I must speak carefully. This is not proven. It is not something we can announce as fact. No observer has watched a universe emerge inside a black hole. No signal has returned from beyond an event horizon carrying news of another cosmos. We have mathematics, possibilities, and deep questions, but not final evidence. Still, even a speculative idea can be useful if it forces the mind to see the universe from a new angle. And this idea changes the question completely. We usually ask, what happens when something falls into a black hole? But perhaps we should ask, what can a black hole become? If the answer is only a singularity, then black holes are the universe's graveyards. They collect matter, light, stars, planets, and information, and carry them toward an ending our equations cannot fully describe. But if the answer is a new expanding space-time, then black holes become something else. Not graves, seeds sealed inside darkness. Now comes the next mystery. If our universe was born this way, why does it not look like the inside of a black hole? This is where imagination must be disciplined. A simple black hole sitting in our universe is not automatically the same as our expanding universe. The geometry is different. The conditions are different. The mathematics is subtle. If we pretend the whole observable universe is just an ordinary ball of matter in empty space, we will mislead ourselves. Our universe is expanding on large scales. Distant galaxies recede because space itself grows. The early universe was hot, dense, and expanding everywhere, not exploding from one central point into empty space. There is no known center of the Big Bang inside the universe. Every location sees expansion in its own way. So the claim we are definitely inside a black hole is too strong. The honest version is more delicate. There are speculative models in which black hole interiors, gravitational collapse, or quantum gravity bounces might connect to the birth of new universes. That is not the same as saying we already know it happened, but the possibility is powerful because black holes and the Big Bang seem to share a disturbing family resemblance. Both involve extreme density. Both push known physics toward its limit. Both force us to ask what spacetime does when compressed beyond ordinary imagination. At the beginning of our universe, our equations point backward toward a hot, dense state, where space itself was much smaller and more energetic. At the center of a classical black hole, equations point toward a singularity where curvature becomes infinite. In both places, the same warning appears. Our theories are not complete. So perhaps the deepest connection between black holes and the Big Bang is not that one definitely creates the other. It is that both are doors into the unknown physics of spacetime. Now ask another question. If universes can reproduce, what kind of universe would become common? Imagine, only as a thought experiment, that every black hole forms a daughter universe. Imagine that each daughter universe has laws, almost like its parents' laws, but with tiny changes. A slightly different particle mass, a slightly different force strength, a slightly different rule for how stars burn. Most changes would be disastrous. A universe might expand too fast for galaxies to form, or matter might remain too smooth, or stars might burn too quickly, or heavy elements might never be made. Such a universe would be sterile, not necessarily in the sense of life, but in the sense of black holes. It would not reproduce much. But another universe might have laws that make many massive stars. Those stars die. They form black holes. Those black holes create many more universes. Over many cosmic generations, the universes best at making black holes would leave the most descendants. This is the strange idea of cosmic natural selection. Not survival of animals, survival of laws. A universe becomes successful if its physics produces many black holes, and now the idea becomes almost poetic. A universe good at making black holes is also good at making stars. A universe good at making stars is good at making heavy elements. A universe good at making heavy elements is good at making planets. And a universe good at making planets may sometimes accidentally make life. So perhaps life is not the goal. Perhaps life is a side effect of a cosmos shaped to make black holes. That thought is humbling. We like to imagine that consciousness is the grand destination of the universe. We look up and think the stars are meaningful because we are here to see them. But perhaps the universe was not tuned for us directly. Perhaps it was tuned for collapse. For stars massive enough to die, for gravity strong enough to close space-time, for black holes numerous enough to seed further realities. And in that same process, carbon was made, oxygen was made, planets cooled, oceans formed, chemistry became complex, eyes opened under starlight. If this idea is true, then we are not outside the black hole story. We are one of its consequences, a mind made of star ash, living in a universe that may be good at producing the very darkness that allows universes to continue. But now we must return to honesty. This idea may be wrong. It may be impossible to test. It may be only a beautiful structure built near the edge of mathematics, where our evidence becomes thin and our imagination becomes loud. Physics is not allowed to believe something merely because it is beautiful. Beauty can guide the question. It cannot replace the proof. So we must hold two thoughts at once. First, black holes may be connected to the birth of new universes in ways we do not yet understand. Second, we do not know that they are. That tension is not weakness, it is the discipline of science. The universe is allowed to be stranger than certainty. Now return to the black hole itself. From the outside, it may look simple, a dark sphere, a shadow, a boundary, a gravitational presence. But behind that simplicity may be the deepest question ever asked. Is the end of one space-time the beginning of another? If the answer is no, black holes remain astonishing. They are still the places where gravity wins completely, where time and space exchange roles, where light loses every road home, where our best theories are pushed to their breaking point. But if the answer is yes, then the cosmos is more fertile than we ever imagined. Every galaxy becomes a garden of possible universes. Every dying massive star becomes a cosmic seed. Every black hole becomes a hidden beginning. And our own universe may be one branch in an immense, invisible tree of realities, a tree where roots are horizons, where seeds are collapses, where birth is hidden behind darkness, and where every universe that learns to make black holes may give rise to more universes beyond its own sky. This is not something to believe blindly. It is something to wonder about carefully, because wonder without discipline becomes fantasy. But discipline without wonder becomes blindness. The great questions live between them. So when someone says a black hole is simply a place where gravity is so strong that light cannot escape, you can say yes, but then go further. A black hole is a place where the future bends inward, a place where our equations point toward the edge of their own power, a place where matter vanishes from our story, but perhaps not from all stories, a place that may be the universe's most perfect prison, or its most secret womb. That is why black holes disturb us. They do not merely hide objects, they hide possibilities. They make us ask whether the cosmos is a single event or part of a larger process. They make us ask whether creation happened once or whether creation is happening constantly, sealed behind horizons we can never enter and return from. Maybe our universe is alone. Maybe it is one of many. Maybe black holes are endings. Maybe they are beginnings. Maybe the word inside itself becomes too small when space-time bends this deeply. But one fact remains. Every time a black hole forms, the universe creates a boundary beyond which knowledge cannot return. On our side, we see darkness. On the other side, if there is another side, there may be a future larger than anything we can imagine. This is the terrifying beauty of black holes. They are the simplest objects we know from the outside, and perhaps the most complicated realities within. They are darkness with mass, silence with gravity, an ending that may not be an ending. So look again at the night sky. Every star you see is a furnace fighting gravity. Every galaxy is a city of light built around invisible forces. And scattered through that darkness are places where gravity has won so completely that even light cannot bring back the answer. But perhaps the answer does not disappear. Perhaps it grows elsewhere. Perhaps somewhere beyond our horizon, a new space-time opens, expands, cools, forms particles, forms stars, forms worlds, and eventually forms minds that look up and ask the same question. Where did all this come from? And maybe far above them in a parent universe they can never reach, there is only a black hole, silent, dark, ordinary from the outside, infinite from within. That is the final mystery. Not whether black holes destroy, they do. Not whether they bend time and space, they do. But whether destruction in the deepest laws of reality can sometimes become creation. If that is true, then the universe is not merely filled with black holes. The universe may be continued by them, and the darkness we fear most may be the place where new light is born. What feels more disturbing to you? That black holes might be the end of everything, or that they might be the beginning of something we can never see? Subscribe to explore more mysteries through the questions that still lead humanity to the edge of reality.